Hi there, Math 148, Section 9.6. We have two more derivative rules. We have the chain rule and the power rule. Doesn't that sound very impressive and, I want to say powerful. I guess that comes in with chain rule, power rule. It's very like monster truckosaurus. And that's the power and excitement that we're bringing to this section, Section 9.6. So the first rule that they have is the chain rule. And the chain rule, this is on page 600, booking right along through the book. It basically says if you have a function where, let's say y is equal to f of u, and u is equal to g of x, try to picture this, it'll be easier to see it in an example, but then the derivative of y in terms of x is just the derivative of y in terms of u times the derivative of u in terms of x. So this is maybe hard to understand or really have this sink in, but I think the easiest way to look at these is with an example. I actually like example 2 in the book on page 600. So what they have here is they have y is equal to the square root of x squared minus 1, like that. So you think, well, there's no u's here, there's no f of x and g of x, you just have a y and an x. So when I was learning this, we called this substitution. You'd say, let u equal x squared minus 1. I think maybe I called it the substitution rule, but then we also didn't have the internet, so a lot is different, people. So we could say now we can write y as the square root of u, okay, because of this. So dy dx is equal to, if you think of this as u is u to the 1/2, we use our power rule, it's, sorry, dy du is 1/2 u to the negative 1/2, and you're probably thinking that doesn't help us much, but wait for it. And then we'd say, well, so we're following this part of the function, that's right there. So for this piece, we do it like this. You say du dx, the derivative of u in terms of x, well, that's just 2x, right? So now we have, as our derivative formula, we have dy dx, the derivative of y in terms of x, is u 1/2 u to the negative 1/2 times 2x. Now we just plug this part back in and we're done. So that equals 1/2 x squared minus 1 raised to the negative 1/2 times 2x. The 2's cancel. I'm running out of space. Okay, last part of it here, I'll make it blue over here, and the whole thing becomes x divided by the square root of x squared minus 1, because that is x squared minus 1 to the negative 1/2, so it looks like this. Anyway, so this chain rule, if you want to do a substitution like this, that works. Some of you, if you do a couple with a substitution, a u substitution, then you will get the hang of it, and you might just sort of, you know, kind of skip the actual substitution step. And let's look at the power rule. The power rule, which is really similar to the other thing that I was calling the power rule. So apparently my notation is not as clever as the books. Looks like this, power. So if you have a function, you know, and it's y equals u to the n. What is n? N is some number. And then we have dy dx is equal to n times u to the negative 1 times, and then you just take the derivative, du dx, the derivative of what's inside, where u is a function that's differentiable by x. This one is, to me, it feels really intuitive. It feels like what you would want to do. So for example, if you had this formula, this is example 4 You can follow along if you like. Number A, they have y is equal to x squared. They like that x. X squared minus 4x raised to the sixth. Well, if we're going to use the power rule, we can do this. dy dx, the derivative of y. We could also write y prime like that. That's fine. So you essentially do the same thing we were doing before. 6 jumps in front of the bus. X squared minus 4x. You subtract 1 here, so that becomes 5. And now we take the derivative of what's inside and multiply everything by this derivative, which is 2x minus 4. And then you can do some simplifying. So I'm going to do another example here that sort of puts all of this together. Here's number 9. We have h of x equals 3/4 times x cubed minus 2x cubed. That can't be right. X to the 5th minus 2x cubed. 5 I say. 2x cubed plus 5. So, to do this derivative, h prime of x, so this coefficient, we can leave this out in front. The 3/4 can stay out in front. Now we're going to use our power rule. So we have this derivative, this power exponent. It pops in front. I always think of it as it jumps in front of the bus. Good job. Thanks, 8. It's saving itself, stopping the train. X to the 5th minus 2x cubed plus 5. We subtract 1, that's 7. And then now we multiply everything times the derivative of the inside. So take the derivative of this piece, which is 5x to the 4th minus 3 times 2, 6x squared, and that would be plus 0, so I'm just going to leave it. And in this case, we can do a little bit of simplifying. There's a 2, 8 and 4 leaves a 2, and that leaves us with 6 times x to the 5th minus 2x cubed plus 5 to the 7th times 5x to the 4th minus 6x squared. So with a lot of these problems, you quickly reach a point where the remainder of the problem becomes simplifying it and trying to confirm that you have this problem in the same form that the book has it in. So I will show you another one here. Hold on. Number 25. It's a little bit more, it's not quite an application, but it's looking at a little bit more. It says, at the indicated point, find the slope of the tangent line and then find the instantaneous rate of change at that point. So we have y is equal to, for question number 25, the square root of x cubed plus 1 at the point 2/3. The point 2/3. So the first thing we want to do, in order to find the slope of the tangent line, you're probably seeing a pattern here, the slope of the tangent line at the point. In order to find that, we have to first take the derivative. Of course we do. We're all derivatives all the time. So y prime, note that this is x cubed plus 1, you want to think of it as to the 1/2. That will make the power rule a little bit more straightforward. So, power rule, 1/2 jumps in front. We have x cubed plus 1, and then subtract 1, that's to the negative 1/2. And now we're multiplying times the derivative of what's inside. So that's 3x squared. So you can write all of this. It looks like 3/2 x squared all over square root of x cubed plus 1. Well, this is just the equation that gives us the slope of the tangent line at any point. But if we want to do it at the point 2, 3, we have to plug in x equals 2 into this equation. So when we do that, we get the derivative y evaluated at the point x equals 2. This is kind of a little bit messy notation. I have 3 times 2 squared, right? That's 4. I'm just going to write the 4. I'm skipping that. 2 squared is 4. Divided by 2 times the square root of 2 cubed is 8 plus 1. Oh, hallelujah, we got a square root of 9. Doesn't that make your heart sing? So on the bottom we have 2 times 3 because all of that is 9. Square root of 9 is 3. And on top we have 12. Oh, these numbers make you feel so good. It's just like everything's canceling. It makes you feel like this is exactly as it should be. Everything is right with the world. 12 divided by 6 is 2, so that's the slope of the tangent line. So part A said find the slope of the tangent line, so that's great. Check, did it. Part B says find the instantaneous rate of change at that point. In the instantaneous rate of change is the same as the slope of the tangent line, which is the same as the first derivative. So again, we have 2. Now your calculator, if you have a nice TI 83 or 84, it can do this evaluation of the derivative, but I do not believe, to my knowledge, it will not give you the equation of the derivative. So you're welcome to check this, to find the formula. You can plug into your calculator, and there's another video that shows how to do it on your calculator. You should be able to get 2. So it's a way to confirm it at the point, but it doesn't actually give you this formula. So hopefully this helps you tackle these problems using this chain rule. And I sort of gave up on the substitution. I don't think you guys really need it. I think it's enough to just use the power rule, bring the number in front, and then take the derivative of what's inside. The old method we used to teach where you do a u substitution, where you'd say let u equal x cubed plus 1, I don't think that's really a helpful step. So I'm sort of glossing over that and moving just to this stage.